Hey guys, welcome back to the Tech Tutor. In today's video, we are going to go over what are linked lists and how they are such an essential data structure. Let's start. So, linked list. A linked list is a sequence of items arranged one after the other. Each item in the list is connected to the next item via a link. As you can see, each of these blocks you see over here, they're connected to each other using this arrow mark. And this is a link that connects each of these data structures, each of these points to the other. Okay, so we have a specific name for each of these data blocks. Each item that is placed together with the link to the next item, it is result in a component known as a node. Okay, so each of these data blocks you see over here, these are nodes, and they're connected using links. Now, let's see how we would want to declare a class for a node, right? How would we want to implement this in a class? So we could define a struct in C++. And when we define this struct, we could call it typedef. We could name it, use a template to call it, right? An item. And in the item, it has one part of it is the data, and the other part is the link, the pointer that it has to the next node, the reference that it has to the next node, basically. Okay, so it has two things, the item. So this item over here, let's take, for example, this. This has the data, which is 12.1, and it has a reference to the next data point, which is the link over here. Okay, so a struct is a special kind of class where all the members are public. In this case, there are two public member variables, the data and the link. So whenever a program needs to refer to this item type, we can use the expression node item. Okay? Now we come across some more terminology, head pointers and tail pointers. So usually programs do not actually declare node variables. Instead, the list is accessed through one or more pointers to nodes. Okay, so if we want to access this item, for example, we are not just like for how we were doing in arrays or vectors, how we were just calling the index, right? That's not how we're going to do over here. We're going to call it using the reference that each of these previous data members, that each of these previous links have. Okay, so this is known as the head pointer. Okay, so it comes like at the front, and the tail pointer, it comes at the end. Okay, and this is the code how this would kind of look. Again, this is the node when we're kind of defining what the node is, and these are the two pointers that we now added to our linked list. Okay, now as you can see over here, for the 14.6 over here, it's not pointing to anything, right? I mean, it's pointing to, it's not pointing to, it doesn't have anything after, okay? So that's when the final node in the linked list does not point to the next node. If the link does not point to a node, its value is set to null. So null is a special C++ constant from the standard library facility. The null pointer is often written 0. Okay? So that is for, as you can see over here, now we have null over here. The use of null pointer, we do it for the last node of the linked list. Now, when the list is empty, both the head pointer and tail pointer are null. That's something we need to remember. When creating a new linked list, though, it starts out empty. Both tail and head pointers are null. So any link functions you write should handle the case of an empty list, when the head and tail pointers are null. Okay, so suppose a program has a built-in linked list like this. Okay, so the head pointer is pointing to a node. Okay, now we want to ask ourselves, how can we set the value of the item inside the node? Okay, so as you can see over here, the head pointer, the data it is equaling to 4.5. Okay, and now we're trying to print out that data. Okay, so the head pointer expression means the data member of the node is pointed by the head pointer. Okay, so basically this symbol, you're gonna see this arrow mark over here where it's gonna point to it. Okay, it's gonna point to the data. Okay, so the head pointer is gonna point, it's gonna point to this data, as you can see over here, right? So the first node that the head pointer is gonna point to is 4.5. Okay, now if we want to print out this data, right, we could say head pointer, reference arrow mark data. Okay, so that's like a reference to the data point. Okay, so this is really important. This arrow mark you see over here, it's actually referencing to the next, and that's gonna help us access the next nodes. Okay, now we come across two common pointer bugs. Okay, so the first one is attempting to dereference a pointer via star p or p arrow mark, right? When p equals to null, right? That could cause problems when p is null. Okay, we could also have problems when we're trying to dereference a pointer via asterisk, or we could call it star, or whatever, p or p arrow mark when p is not properly initialized. But note, this error does not cause a syntax error, but instead it could cause errors like a bus error, a segmentation. You might have come across the segmentation fault, segmentation violation, address protection violation. Okay, so it's important we know what we're dereferencing. Okay, so this is one of the functions that we could do with a linked list, computing the length of a linked list. Okay, as you can see in here, we're defining this method over here, and we're passing in the node. Okay, the head pointer. Okay, and then this for loop basically over here, right? It's gonna start from the head pointer, and we're saying we're gonna have a, like how we said, for integer I equals to 0 as like this counter variable, right? Here we're having a node that's gonna be our counter, that's gonna go up 1. Okay, so for cursor equals to head pointer, and the cursor is not equal to null. Okay, cursor equals to cursor, so it's gonna point to the link. Okay, so it's gonna keep going on to the next node until what? Until there's a null value. Okay, and then finally it's gonna return this answer. Okay, here we kept it as a signed int because we know it has to be positive, right? Okay, now let's look at this visually. So we have the cursor equals to head pointer pointing at this first. Okay, then as per our for loop, it has to point to the next link. Okay, as you can see, it's pointing to the next link now, and as this is happening, the answer is getting incremented by 1. Okay, it goes doing that until it finds that the link for this node, the third node we have, is null. Okay, and it finds that it is null, and that's when it knows it needs to stop. Okay, so the code again, and now we also come across a lot of other operations that we could do with linked lists. Okay, for example, inserting a node at the list head. Okay, so if we want to insert a node over here, inserting a node not at the list head, say we want to insert at the middle. Okay, then inserting searching the list for an item, because now you cannot just say I of 5, right? The array of 5, right? You have to actually traverse it and search it, right? Now locating the fifth node, let's say if you want to know what the fifth node contains, traversing that, right? Removing a node at the list head, and removing a node which might not be at the list head. Say if it's over here, if you wanted to remove this 14.6, right? You would have to traverse. Okay, so again, some more of these operations: list clear, empties a list, when we want to delete all the nodes. If we want to copy a list, right, and all of its nodes, then that could also be one of the things we want to do. Now let's look at one of our tools that I mentioned in our last video that will help us understand better how these actually work. Okay, so let me generate a random list of nodes. Okay, so we have 3, 12, 7, 9, 10. 0, 6. Again, do you see it? All of these have arrows, except for this last one, which is null. Okay. Now say we want to add 1 at our head, okay, at our head pointer, okay, at index 0. Okay, so let's say add to front. Now look, I want you to look at this process. Let me slow it down a bit more. Let's say we want to add 23 at index, add to the front. Okay, look how that it's gonna put it into a node. Gonna reference, and this visualization is pretty cool. I'm gonna slow it down a bit more because I feel okay. So let's see what it's doing. It's gonna put it in a node. It's gonna put 32 in a node. You're gonna reference that. It's gonna point to the next, which is in this case is 23, and the head pointer is gonna point to this. Okay. Now, if we want to add to the back, right, that's gonna look different. Let's say we want to add 332, add to the back. Okay. So it's gonna, again, you will see now it's gonna traverse, right? The important thing is gonna be it's gonna traverse, keep going. Okay, let me increase the speed a bit. Okay, yes, you got it to 9, 10, 0, 6. Now look what happens. Now it's not this link is not going to be null anymore. It's now going to point to the new node that we have, 332. But now 332, right? It's going to contain the next link, the next reference to the null pointer. Okay. Now if we want to add at a specific index, we want to add to 2, right? Think about where this is going to add it. I want before we go about doing this. Okay. Now see. Oh, so I said 0 over here. Let me do that one more time. Let me put 243 at index 3. Okay, add to index 3. So let's see what happens over there. Okay, so 0, 1, 2, 243, put in a node. Okay, do you see how those arrows are going to be linked to the next one? Okay, and the previous node is going to link it to the present one. Okay, that link, because if you lose those pointers, right, there's a lot of data that you're gonna miss. Say we didn't put this arrow, right, this arrow after 243, we didn't link it to 1, okay, by accident, right? Because we got to do that. We got to make sure we do that. If we don't do that, we're gonna lose all of these indices. Okay, so the reference the present node has to the next node, and the present node has with the previous node is really important in linked list, guys. Okay, so that's basically a brief overview of linked lists. Let's go to our conclusion slide. Linked lists, again, now they provide a dynamic memory location. It makes them more flexible than arrays. Okay, they allow efficient insertions and deletions, but they do come with the trade-offs that we talked about of extra memory overhead due to pointers, and also traversing through them, and inserting them and accessing. Accessing could be a problem. Okay, accessing a specific index could take much more time. So not only do we have we have double linked lists. Okay, so double linked lists and circular linked lists. Okay, just to go back and show you what those look like. So double linked lists, they not only point to the next node, they also point to the previous node. Okay, circular linked list, the tail pointer points to the head pointer. Okay, do you see the tail pointer is going to point to the head pointer? So those are our types of linked lists that we have also. Okay. Okay, so let me go back to our conclusion slide. Okay, so mastering these linked lists strengthens problem solving skills, and it's crucial for technical interviews and real world applications. So do keep practicing by implementing different versions and optimizing operations to enhance performance. All right, guys, thank you so much for sticking around. And if you did like the video, please do like, share, and subscribe. If you have any comments or any feedback, please leave them in the comment section below. And see you next time. Bye.